All right, this is section 8 of your data project, conclusions. So we have gone over gathering data. We've made dot plots to show our distribution. We have made frequency histograms and frequency tables. We have also looked at the measures of center. Why can't I find that page? We found the measures of center. We found the measures of variability. We have also made box plots of the data. So you are now going to use all of this information to make conclusions. This is why scientists and economists and all sorts of people who study different things look at statistics. They make generalizations about what they've learned. So, what do your measures of center tell you about your data? What does it mean? Okay, so when we looked at our measures of center, we had a mean of 75.5, a median of 77, and a few modes because they only repeated twice. So what does this mean to us? Well, the measures of center tell us where a typical person might be. In this case, it was people. Depending on what you were measuring or interviewing about, yours might be different. But this tells me that the typical pointer finger of an adult will probably be between, so we had our mean and our median. I'm using both of those to make this generalization. I'm going to say between 75 to 77 millimeters long. That's what it tells me. There's going to be people that are smaller than that. There's going to be people larger than that. But that's kind of where the general center of the data is. Okay, what do the measures of variability tell you about your data? What does it mean? Okay, let's look at our measures of variability. We had a couple that we did. We looked at the lower quartile and upper quartile. We look at the range, so it's spread out across 22 numbers, but the middle half was 10. Looking at those, this is just double. Well, this is the whole thing, and this is the middle half. That kind of tells me everything is fairly close together. So what does it tell me? I can guess that most fingers, or pointer fingers I should say, because that was specifically what we were measuring. Most pointer fingers on adults are between 60 to 90. I only interviewed 18 people, but based on that, I'm guessing that most are between 60 to 90 millimeters long. You're probably not going to see any longer than that or many shorter than that. We can also see from the mean absolute deviation, oh, that was on this page. You can see from the mean absolute deviation, it's pretty small. We also saw how far most of them were from each other. That the data is pretty evenly spread out. Okay, so that would be the distribution. So distribution, would you say it was symmetrical? Well, one way I can say it's fairly symmetrical. Look at this distances right here. I can see that the distance between this half and this half is pretty dang close. Where else can we see it? Well, looking at our histogram, I don't see any symmetry here. Also on our dot plot, I don't see a lot of symmetry, so I guess it's not really symmetrical, but it is kind of evenly spread out. We don't have any big gaps kind of have a gap between 64 and 67, or between 65 and 66. So there's a couple of small gaps. It looks like we've got quite a few kind of clustered up in here, but nothing majorly clustered. There's not any major peaks. We've got a couple of numbers that repeated themselves. So after looking over all of these things we did with our data, what can we say about the distribution? There is a gap between 65 to 66. It's not symmetrical. Looking at the graphs and dot plot we made, but it's fairly evenly spread out. Okay, some of you are going to do data and you're going to find that almost all of them are the same number. It just depends on what you are measuring. Okay, what would happen to our mean if we took out the outliers? Well, in this example, there's no outlier, so it wouldn't affect the mean. In your case, if you have an outlier, what would it do? Would your mean be lower or higher than it is currently? Now, what did you learn about the data you gathered? What was the most interesting thing about your data? Okay, this is your interpretation of your data. I'm going to interpret mine. Something interesting I noted was that it seemed the men's fingers, look at everyone that says Mr. 83, 78, 80, 84, 86, 83, 76. Okay, I found it interesting. Then maybe I might want to do it. I might want to do two of these to compare women's hands to men's hands, because it seemed to me like the men's hands were a little bit bigger. So it seems that the men's fingers were all above 75 millimeters long. There was a couple women that were up in there, but all the men's were above 75. So I thought that was kind of interesting. Something else I learned from this data is that it looks like most fingers were different lengths. It didn't have a lot of repetition. That might change if I were to interview a lot more people, but I didn't have a lot that were the same length. Only repetitions of 2. Now, what predictions would you have about data from a group of 100 instead of just 18? Alright, so this is where we're going to use our numbers that we've already looked at and make guesses about what we would expect from 100 people instead of just 18 people. Well, one thing I would expect is I think there would be more repetition. Because you're more likely to have more fingers similar in length. Okay, another thing I could possibly say, okay, to back this up, remember our relative frequency? We had a third, 6 out of 18 reduces to 1/3, or 33%, of our data was between 79 and 83. So based on that, if 33% was between that space, I'm kind of guessing that we'd have at least about a third that are that length out of the 100. So I'm going to guess that 1/3 of them would also be between 79 to 83 millimeters long. So 1/3 of 100 would be somewhere around 30. Okay, you see how we made that based on 100? If 1/3 of them for our small point of data was that, so about 30 would be about 1/3 of 100. What else would I expect? I'm kind of thinking that we'd probably find out more men's hands are bigger than women's hands. But this is where you make up predictions based on what you see. All right, how could any of your statistics be misleading if you used it that way? What could I do to make this misleading? If I use my modes, I might make you think that I had a lot of people who had finger lengths that were, I could misuse my mode. I could use my modes to make you think that a lot of people had fingers that were 67 millimeters. In reality, did I have a lot that were there? No. If I just said that was one of my modes, you don't know if it repeated twice, which is what it really did, or if it repeated 100 times. So we could use a mode to make you think that a lot of people had fingers that length, when in reality, based on what I have, is that true? No. If you had an outlier, you could use that mean to make it seem misleading. You could use a median to make it you think that things are too high. Statistics is all in how you sell it. So that's why you need to be also smart when it comes to reading statistics and look deeper into the information. Okay, when you're done with that, you're going to staple it all together and turn it into me if this is your personal project. Or if you're online, take pictures and turn it in on Google Classroom.